Hi, welcome back to Cloud Patterns. In today's episode, we'll talk about high available messaging with Windows Azure Service Bus. Systems don't live in vacuum. Many systems need to work together to accomplish complex, distributed operations. When we integrate different systems together, the most obvious way is to allow these systems to directly communicate with each other. However, as the number of systems increases, we'll face two problems. First, there will be many connections to be maintained. Second, these systems are tightly coupled. For the communications to happen, they have to be online at the same time, and their interfaces must match up. One system changing its interface requires all related systems to make corresponding changes as well. Otherwise, the communication will fail. A common approach to fix these problems is to use a broker. Instead of communicating to many systems, a system only needs to talk to the broker, and the broker will provide necessary features such as reliable messaging, message transforms, dynamic routing, broadcasting, and other integration concerns. This intermediary not only decouples the system, but also separates integration concerns from these systems. However, because many systems rely on this intermediary, it has to be highly available so that it doesn't become a single point of failure of the integrated system. Windows Azure Service Bus is such a broker system. In this episode, we'll summarize existing and new Service Bus features that enable high available messaging among systems. Service Bus is built on Windows Azure platform. When users subscribe to Service Bus, they get an endpoint representing the subscribed service, and then they can use the endpoint to communicate with each other. Now let's peek inside the data center. Behind each endpoint is a Service Bus entity such as a queue or topic, and each entity in turn uses a message broker to handle the messages, and the message store to preserve messages. So Windows Azure Service Bus relies on Windows Azure data storage services to preserve data. It relies on Windows Azure computing power to host the messaging logics, and it relies on Windows Azure Data Center to provide continuous service. Any of these components may fail, rendering the Service Bus service unavailable. How do we plan and deal with such kind of failures? Because there are so many components involved here, we need a comprehensive solution. This is the question that I want to get some answers for. So I'm going to make a field trip to our Service Bus team, and hopefully we can get answers directly from the engineering team. Here we go. Okay, now I'm in the office of Abhishek Lal, the Senior Program Manager of Windows Azure Service Bus.
Welcome, Hashi.
No, thank you. This is a really cozy and warm office.
It's a nice sunny day today.
Yeah. Actually, I was talking to my audience about the questions about the Service Bus high availability. So I came with some questions. So nice. I hope I can get some answers from you.
Oh, absolutely. I'll try to answer the question.
So the first question I have is that for a typical scenario, I'm a user of a Service Bus service. Right. I subscribe to a queue or topic. Then I stand to send and receive message from it. But of course, there are a lot of things going on behind the queue.
Right.
Can you give us some more details of what's happening behind the scenes and what Service Bus does to ensure the high availability of that queue entity?
Absolutely.
Yeah.
Absolutely. Talk about that.
Okay, guys,
so,
all over this place.
Here we see a typical sort of expression of where you see there are several queues, and these could be queues which you have created, or from our service perspective, this is a multi-tenant service. Service Bus is a multi-tenant service. So we can have queues from different tenants which are being processed by the system. The broker is sort of what the service side piece is, what you're interacting with. She has already showed you that there are sort of your entities, your metadata in front, and then there's a messaging subsystem and a storage subsystem in all those ways. And I just want to call out that in all of those layers, we've built different types of redundancy, different types of availability characteristics, so that your particular endpoint to which you're talking to never has single points of failures. And even if it does, then what are the approaches which we take in terms of avoiding that is what I'll be explaining a little bit today. Now, in this case, you have all of these different queues. They can be running on different instances of the broker, right? So you can say Q1 and 2 are running on one sort of broker node, and Q3 is running on another broker node. So the first layer of redundancy really comes in the system is that if one of the broker nodes, which is your sort of compute layer and your initial authorization layer, the front end layer sort of experiences an outage, then these queues can very easily be load leveled into another broker. So that's the first layer of availability which you see. And these times in terms of moving from one particular compute node into another compute node where your messaging logic is running are really, really fast. They're fairly small. And the reason for that is because all the stateful information for your particular queue, which is all your messages and session state and everything, is in a store where the compute layer is fairly stateless and it can hand over that information to another node, and that node can then hydrate from that same store and run. So these essentially give you availability from where there are network failures, like this broker node may no longer have network connectivity, or there are actual hardware failures where that CPU or that machine or that box may go down, or it may go through some kind of healing or upgrade process. And then of course at a software level, let's say if the broker code has hits a unknown bug or something like that, and it crashes or something, all of those cases we protect you from a single node failure. Your queue is now processed by any other of the node, and all of these nodes form a ring, and it's a highly available ring and a fairly big ring to service all those needs. So this is sort of the top level view of where you are seeing that a single queue can be processed in terms of several messaging broker nodes, and thus you have high availability.
So this reassignment of brokers, it all happens automatically. Do I need to do anything just to control that or enable that?
Right. So from your perspective, I can say there's a couple of things here. So this reassignment happens completely automatically. You're completely shielded from that. What you would see is, I would say, a couple of seconds of errors or something while the connection reestablishes to the new node, and the new node hydrates all your state, and you're up and going. Now apps which are very sensitive or high throughput and high load kind of this thing, I would suggest then the next step you can do is create multiple queues.
I see.
Now the advantage you get of multiple queues are, again, these queues are all sprayed across different nodes in terms of the broker. So even if one broker goes down and you're going round robin between queues, your Q1, which may be affected by a particular broker failure, your Q2 will continue to work, because that's how the system just isolates and partitions. So in that sense, one advice to customers would be is to partition your load across several entities. You can create several queues. And there again, as you can see, by creating several queues, you're getting more throughput in the system. You're able to go spread your load across different nodes, and hence get a little bit more availability.
Okay. So I'm coming back to the picture. So from the perspective of a client, if this is my queue client, so I've maintained multiple entities just to segment my work and to ensure the higher availability of my messaging pipe, basically.
Correct. Right. So the next part, Hashi, which we want to talk about is what is the impact of the store, the messaging store. Is there a particular area you want to focus on?
I mean, this store is even one layer behind the broker, right? Right. The stores can fail as well. Right?
Correct.
But for that, as a consumer of the service bus, I really don't want to
manage those kind of failures.
Correct.
So
Correct.
I'm relying on service bus to do something for me. Basically.
Perfect, perfect.
Yeah.
So let's talk about that layer. I think the store layer is also very, very key. So I'm just going to draw a message store here. And again, assume that this is a partitioned store, you know, as we have several different layers in there. And assume that a failure happens at one particular store. You know,
I think I need to give you more room.
Yeah.
All of the picture.
Yeah, no, that's cool. So here, if you think about a store being unavailable, you can be impacted by two things.
Mm-hmm.
One is that, you know, the store itself, in our case, is a partitioned as well as highly available store.
Mm-hmm.
So a single piece of hardware failing,
Mm-hmm.
or a single disk failing,
Mm-hmm.
or you know, one particular network path failing will not cause a store outage in there. So we are using a distributed and partition store. But just from a consistency perspective,
Mm-hmm.
this store is a highly consistent store because a lot of our features are very consistent messaging.
Yeah.
So, you know, first in, first out kind of consistency. If you ask for a message or the queue count, we are very accurate, how many messages, you know, you have message count and things like that.
Mm-hmm.
So it's a very highly consistent system. And when there is a consistent system, it has to use a very consistent store.
Yeah.
So when failures do occur, here's again a case where you can imagine from your perspective, if a particular store is unavailable, we do not have now the state of that entity, right? What are the current messages in it and things like that.
Yeah.
So there are several layers of you know, availability which we have built in there.
Mm-hmm.
The first one I want to talk about is if an entire store is unavailable, now any messages you already had there, we are unable to process because, you know, we don't have the state in there. But what we will do is for applications which want highly available send,
Mm-hmm.
where the idea is they should still be able to send messages, we can temporarily store those in a different store, right?
Okay.
Now, the advantage you get out of this is your application can now keep sending messages, and even if the particular store you were tied to is unavailable, we will use other stores and start sending messages to them.
Mm-hmm.
Now, on the receive end though, because you wanted to maintain the same high level of consistency, ordering and sessions and all of those things, we might not return any message to you
Mm-hmm.
till the primary store becomes available.
I see.
So from an end-to-end application latency perspective, you might see that, you know, messages are taking a long time to go
Mm-hmm.
through the system till the out, you know, store which is out is not available.
Mm-hmm.
But from a send perspective, you don't have to lose any data because typically we see senders are stateless.
Mm-hmm.
There's a web role which is probably sending information, or there are mobile clients which
Yeah.
are sending messages.
Yeah.
They don't have very long to, you know, deal with an outage and then resend and retry and things like that.
Yeah.
So you might see, you know, a couple of errors. When you retry, we'll give you a separate store. We'll put the messages in there and you move on from there. So from a send perspective, we are giving you highly available send in there. But what would you do to actually get end-to-end send and receive availability, right? Where you actually want to be able to say that even if this store is unavailable,
Mm-hmm.
how do I now make sure that I can both send and receive messages? Well, to get some, you have to give up some, right?
Yeah.
And the key thing you would give up in this case would be your standard sort of message ordering, let's say.
Yeah.
Because even though you have a message backlog which is built up,
Mm-hmm.
that may be in an unavailable store,
Yeah.
but you still want to receive messages from the available store,
Yeah.
right? And for this, folks, we're offering a new partitioned entity.
Mm-hmm.
When you think of partitioned entity, the same way as what you achieve with different queues,
Mm-hmm.
now we will give it to you automatically, where a queue will not only be processed by several brokers, but the same queue will be backed by several stores.
I see.
So now you're not even isolated or in terms of, you're not constrained to a single store from an availability perspective, but if the entire store is unavailable,
Mm-hmm.
you'll still be able to send and receive messages from another store.
Mm-hmm.
So a great up level in terms of your availability characteristics in there.
Yeah, actually, I like the design a lot. I mean, for a lot of applications, based on the different scenarios, I may only need high available SAN.
Right.
I mean, if my client or web role is using a service queue to decouple the backend,
Back end from the front end.
basically the front end is in a fire and forget mode,
Correct.
Anyway, I mean, I just want to keep my front end working and fire the events.
Right.
If it's processed later, it's great. If not, it's not a terrible thing in many cases.
Correct.
But in other cases, if I do want this high available send and receive, I can just trade off some features to see, hey, do I really need a strict ordering? If I don't, I can achieve this by using the high availability send and receive.
Correct.
So, but for this thing you just talked about, that a queue is backed by multiple brokers and stores. This is in the current version, or it's in the upcoming version?
Right. So we're going to release this as part of the next SDK release.
Okay.
When it's going to go GA available. We do have it in preview form where customers can look at it.
Okay.
And Hashi, if you'll be kind enough to share the API of how to create it.
Yeah, I will try that tonight.
Okay,
Yes.
perfect.
Actually, it will be shown at the end of this episode. Yes.
Perfect.
Yeah.
So then you'll be able to see how easy it is to create that and achieve your sort of basic scenarios in a much more available kind of way.
Okay. Yeah. But since just now we were talking about trade-offs to give up something in order to achieve some scenarios,
Right.
how about sessions?
Ah,
Yes.
right. Very good point. Very good point. So let's say generally people think about transactions.
Yeah, I'm going out the picture again.
Okay. That's good. So folks think about transactions and ordering and sessions in a lot of applications. And Service Bus, one of the key differentiators has always been these very highly consistent messaging kind of features. If you do want ordering and you want to take advantage of the high availability features and partitioned queues which we are delivering now, we have made that completely consistent. Let me explain that to you. So the same way as you would have a single queue which is backed by multiple brokers and multiple stores, right, in there, we will now pin particular sessions to particular stores. Which means that if you have session 1, it could go to one store, and then session 2 would go to another, and session 3 would go to another store, and so on and so forth. So what it means is that within a session boundary, you are getting high consistency.
Yeah.
You can do strict ordering in terms of a single session. So a great advantage there is that if you do session ID property, which as you're aware is fairly easy by just setting a session ID property on the broker, on the brokered message, you are still going to see strict ordering and strict availability in there. And you can do transactions across that, where you can do receive a message, process it, complete it, and call all of that in a single transaction, and things, and update session state and stuff like that. Let's consider what that does for availability, because that's sort of the key topic we're discussing today.
Yeah.
If I have session 1 pinned to a store and session 2 pinned to another store, right? You can imagine that if one store becomes unavailable, any existing sessions which are pinned to that are unavailable at this point. That's the price you sort of pay for that consistency. But if you're creating new sessions, which is again a sender scenario of just creating new orders could be sessions, or creating new user end-to-end sort of request response sessions, then those will continue to go to other stores and would be completely available. So only the sessions which are in flight and pinned to an unavailable store are the ones which could be affected. New sessions would not be affected.
Okay.
Again, we are partitioning all the way across different stores for you. So again, using different session IDs, we will make sure that they land on different store backends and things like that. So here is a very, very easy way of now taking your app and actually making it work with where ordering is important and transactions are important, and still achieve high availability.
Yeah.
It's just that the way you will achieve that now is by using sessions and by using partition entities in conjunction with that.
Okay. So this is great. I mean, from a client perspective, I'm still working with queues and topics, but behind the scenes you can see the Service Bus has built-in redundancy and failover on all the supporting layers.
Right. So
we really have high available queues. I guess from the client's perspective, there's really nothing much we need to do to enable this. Right?
Correct.
Yeah. Okay. So as we talk about high availability, service bus, we can't just think of this failing mode. There could be worse things happen.
Yes.
Like the data center crashes or something. Right?
Sure, sure.
Are we prepared for that?
Good
Yeah.
question.
Yeah.
Good question.
Yeah.
So we get this a lot from customers. You're always planning, and that's the right way to plan in terms of at every layer. Like we plan in terms of our compute layer, our front end, back end, our store redundancies. When you take a step back and you say all of this is a box in a data center, right? In terms of that this is all resources running in a physical boundary of a data center. How do I go beyond that? And for that, we have presented a feature called paired namespaces. And what the idea here is that if you look at the namespace boundary for us, it's sort of the management unit under which you create all your queues, topics, and entities and manage them and send messages. And that is the unit which is paired to an actual region. So when you create a namespace today, you get to decide whether to put it in US East, US West, Europe North, Europe West, all of those kinds of, or Asia East and different regions. So what if you could pair two namespaces? Because now the idea is that you're getting this advantage where if an entire region is experiencing an outage, you're not going to be affected by it because you've paired it with a namespace on a different region in there. And that's what paired namespace offers. So let me draw that as a complete box and say, okay, all of this is running, let's say, in US East.
Yeah.
Right?
Yeah.
You would create a service bus in US West, a namespace.
US West is out of the screen.
Okay. That's fine. So
yeah, just imagine there's another box.
There we go.
Okay,
Right.
there you go.
So now we have US West.
US West.
Okay. Cool. So now you have all of your workload running in US East, and let's say US East is experiencing issues and you want to fail over to US West. That's what paired namespaces lets you do. In the paired namespace case, you'll be trying to send to this particular queue, but not only this queue, but all the queues in this region are no longer available. Service bus will detect that. And if you have paired it with a namespace in US West, we will create for you transfer queues. So as the name suggests, these are temporary queues. These are transfer queues, waiting to get your message to the right destination. And again, these clients, which are a lot of fire and forget kind of particular clients, they will now automatically fail over and start sending to these transfer queues. Now, this works on the send side, on the receive side, because you want your same, ordering and sessions and all of that availability, and that data is sort of sitting here. You will not receive messages from here. These will stay here in the transfer queue till this region becomes available, at which point we will siphon the messages appropriately back into the right queues in which they wanted to go. So your receive side logic will either participate in the siphon procedure, which for you is just setting a flag. And I believe she'll be showing the names, the APIs for this too, where you just have to set the right flags of where to enable the siphon. And then we will take the messages from these transfer queue, put them in the original queue so that your receive logic just continues to work in there. But what this gives you is actually geo-distributed failover in the case of there being a very large outage of an entire region, and your send continues to work. It continues to push messages in there.
And for the receivers, it just feels like they don't receive a message for a while, then the region recovers, then all the messages come.
Correct. So for the receivers, again, the end-to-end latency is higher, where because we are maintaining all of your consistency requirements, this is completely supported for sessions. It is supported in ordering. All of those things are fully supported. And that's why you can imagine by the end-to-end latency of the app might look different while the region is unavailable. But from a scenario perspective, if that works for you and you want this next level of availability where you say, I want to tolerate an entire region outage, paired namespaces is there. And actually, paired namespaces available in 2.1, Azure SDK 2.1 itself. It's fully production available for you to use.
So this makes perfect sense. I mean, if I want to have a high available service deployment, what I usually do is to deploy my service to different regions and maybe set up a traffic manager to route the user traffic to different regions. But at the end, if I use service bus, I want that piece to be high available as well. So if I have this failover across regions, that's great.
Right.
Yeah. I think we got a really good story about the high availability of service bus today. I've got all my 3 questions answered. So thank you very much, Abhishek. I think this is great. And I think when I go home, I have some homework to do. I will show you how to actually use this in the code and use the upcoming SDK. But as Abhishek mentioned, it will be really simple. It will be the simplest code demo you'll ever see.
I hope so. I hope we've done our work right.
Yeah. Yeah.
Cool. Thank you
very much. Thank you. Okay.
Now I'm back in my office. I'll just show you quickly how to use the features we mentioned in the episode. Here I've got a simple console application on Visual Studio 2012. And I've added a Windows Azure Service Bus 2.2 NuGet package to my solution. Let me close this. First, I'll show you how to use the paired namespace. And you can see to enable a paired namespace, all you need to do is to use the primary messaging factory and to call the paired namespace async method. And you can give it paired namespace options. And here I'm providing the namespace manager as well as the messaging factory to the secondary namespace. And I'm saying I would like 10 backlog queues, and my failover interval is 5 minutes, and I want to enable siphon on this particular client. Secondly, to make a partition queue, or to make your queue to be backed up by multiple message brokers, all you need to do is to set the enable partitioning flag on the queue description before you create a queue. Then you just create the queue as normal and use the queue as before. So this is a quick code example, and you can see there's really nothing much you need to do to enjoy the high available features of Service Bus. And to summarize, Windows Azure Service Bus provides high available features at various layers. First off, as a developer, you can use multiple entities to segment your workload across multiple Service Bus entities. And you can use partitioned entities so that your entities are backed by multiple messaging brokers. And Service Bus also provides you automatic store failovers so that if one data store fails, you can still leverage other data stores to continue send and receive messages. And we also have paired namespaces, which give you a geo redundancy in case if one data center fails completely, you can still use paired namespaces to keep sending messages. The second bulletin point is not a summary, but to point out that when you use paired namespaces, because there are additional messaging entities and message transfers involved, there are additional costs associated with the feature. You can find more information by these 2 links. And feel free to reach out to us if you have more questions on this. Thank you very much, and I'll see you next time.